Welcome back to BE544. In Lecture 3, we gained hands-on experience with QPath, which is considered as an open-source platform that enables annotation, quantification, and AI-ready data preparation. Today, in Lecture 4, we turn our attention to ImageScope. ImageScope is a widely used industry standard viewer developed by Leica Biosystems for navigating and analyzing whole slide images in SCVS format. While ImageScope is not open source, it remains a suitable tool in both clinical and research settings due to its robust visualization capabilities, precise measurement tools, and compatibility with digitized H&E and immunohistochemistry slides. Although ImageScope doesn't natively support deep learning model integration like QPath, it excels in standardized visual assessment, manual annotation, and quantitative analysis, particularly through built-in algorithms such as positive pixel count, which provides objective scoring of biomarker expression in stained tissues. During this session, you will learn how to open and navigate whole slide images in ImageScope, create region of interest annotations, perform measurements, and apply algorithmic tools to extract reproducible quantitative data. So, let's begin our exploration of ImageScope. You can download the software from this website. By navigating to that site, you will find this interface of the website. You can search for ImageScope and then go to Aperio ImageScope, and then you can download either version of these two versions. If you downloaded the latest one, you will need to fill the following information: your first name, last name, job title, and your role, and your email, and then you can submit. You will find the download link. It will start downloading, and then you need to extract it. After extracting, you will find a folder with the same version. If you open it, you will find the software with an extension .exe. You will need to install it on your computer or laptop. After installing it, you can search for it, or you can find the shortcut on your desktop. You can open it. This is the interface of the application. It's very simple with simple tools. You can add images from file and then open image, or you can press Ctrl+O. And as mentioned in the previous lecture, we are going to use the dataset called PACH, which contains different whole slide images. For example, let's open the first 5 whole slide images with the extension .svs. It will start to import each of them, as you see here. If you click on any of these images, it will navigate to the corresponding whole slide image, as you see here. You can zoom in and zoom out using two options. The first using the mouse scroll wheel, and second, you will find here the different zoom levels from fit to include the whole slide image on your screen, and 1x until 20x. And by dragging the region or the whole slide image using the left click of your mouse, you can navigate and scroll to any of the regions. Also, you have a small screen here with a thumbnail of the whole slide image. You can press on any region and you can easily navigate to it. For example, if you clicked here, you will navigate to that region, and you can simply, without any scrolling using the scroll wheel, you can navigate to 10x or 4x and so on. ImageScope provides simple annotation tools, as you see in the toolbar here. It starts from the rectangle tool. You can press also in F5, function 5, to draw a rectangle, as you see here. You can draw also a circle or ellipse or an oval, like here. You can also draw an arrow or press on F7, like here. And the more you stretch the arrow, the bigger size it will show. As you see here, the more we grab the arrow, it will start to increase in size. You can also use a counter tool to count tissues or nuclei. Simply by pressing on any point, you can start counting. As you see here, we have 10 points. These annotations can be accessed using the annotation function from the view, or by pressing Ctrl+N. You will find the different annotations here. And as you are dealing with the same annotations, you will find that the counters is cascaded to the first layer. This means you can append the different layers. Each layer can contain different counters. So simply, let's delete that by pressing on the double crosses. It will ask you if you need to delete all of the annotations. You can press yes, it will delete all of them. You can add a layer and another layer, a third layer, and by pressing the layer and start to annotate a region, this annotation will be related to the highlighted layer. For example, if we use the second layer, it will start to annotate the second layer, and the same for the third layer. If you went to the first layer, you will find the first region with the length in micrometers and with the area in micrometers square. You can type a description, for example, tumor or benign region or malignant and so on. You can also write a text. This text can be used as classes or keywords for that region, and the same for the second and third layer. If we went to the first layer and start to count, all of the points we are counting will be related to the layer we highlighted. And if we press on the second layer, all of the counts will be related to the second layer. And if you went to the description of the counters, we have 8 counts. Each has an X and Y, and you also can type a text and description for each. If you double-clicked on any of the counts or any of the annotations, it will navigate to that region. For example, if you double-clicked on 5, it will go to it. And if you went to the first layer and double-clicked on it, it will go to that annotation. If you missed and you need to delete only a single annotation or a single count, you simply go to it and press on the delete region here. It will update the counts. It was 12 and now it's 11. But if you clicked the left cross, it will delete the whole layers, while the double crosses, as mentioned, will delete all of the annotations, including all layers. There is also a pen tool, or using function 2 or F2, that can be used as a freehand sketch to a tissue or adipose or a cell using the mouse, and it's recommended to use the tool using a pen and a tablet to be more precise. For example, if we want to annotate that region, let's go to 20x and let's press on F2 or pen tool, and let's use the mouse. While using the pen tool using the mouse, it may not be too precise. So if you have an artifact or a region that you need to delete, you can simply press on the same line and follow the boundary. It will update that region by removing the region that you don't want. For example, if we press here, it will simply update the line as you see. Let's get another example. If we need to annotate that region, and as mentioned, it's recommended to use a pen and a tablet. It will be faster and more precise. So I'm currently using a pen and a tablet and annotating that region. As you see, instead of using the mouse, you can use the pen with more precision. And if we need to exclude the inner region in white here, we can use the negative pen tool. So what included in the negative pen tool will be excluded from the whole region. So let's start to annotate that portion as you see here. And if we went to the annotation, you will find the region labeled with 3 is the outer region and with 4 is the inner region. So we can type a description here. We can say include and here exclude just as a note. You can also have different properties or markers or features for these regions, such as area and length. So as you see here, it's about 7.5 micrometer square. You can also use the ruler tool to measure the distances if you need by pressing on F4 or function 4, or use the ruler tool from here. Let's simply measure the height and width by clicking on a point and grabbing that line to another point. It will measure the length. It's about 175 micrometers in height, and also the width for that will be about 56 micrometer. And if you went to the annotation, the ruler tool will only include the length but not the area, and you can type the description for each of them. You can also change the color of the layer. For example, for the first layer, we are going to change the color to green. As you see here, the whole annotations are converted from the red color to green. Let's remove the second and third layers. As you see, When we deleted the second layer, it moved the counters from being a child for that layer to a new layer and didn't delete it automatically because we are only selecting a specific layer that we need to delete. Let's delete the third layer and let's delete the counters here and here. You can also delete multiple regions from a specific layer or delete multiple layers at once by selecting multiple records. For example, I'm selecting 6 and 5 by pressing the control button from your keyboard and press on the delete regions. Let's delete all regions and keep only these two regions. Let's go the first one and delete it. We have only the third and fourth region in the first layer. You can change also the name of the layer by simply using a single left click on it and change it to any name, for example, region 1. So now we have region 1 with only two annotations, 3 and 4, the outer to include and the inner to exclude. We can change the brightness contrast from adjustments in the image menu or by pressing Ctrl+A. You can increase and decrease the brightness as you need for the whole slide image, as you see here. By decreasing the brightness and increasing the contrast, it can change the visualization and the color intensities of the pixels. You can manipulate the whole slide image so you can identify the nuclei easily or the tissues. And if you need to return to the original numbers, you can press on reset. You can also compare between a specific view to the original view by modifying what you need and then press on compare. This is the original view with zeros in the brightness and contrast, and this is a modified view, so you can easily identify the regions you need and to compare if these two configurations or values are correct. Let's press on reset. You can also, in the color balance menu, you can change the red, green, and the blue colors as you see here. And by default, this option will be checked, keep brightness constant. So when you change any of these three values, it will start to update the second two values as you see here. But if you unchecked this option by changing any of the three values, it will not update other values and you can modify the values you need. You can also compare the original view with the modified view. Let's return to reset. Also in the brightness and the contrast, you can handle any of the three channels RGB. So if you went to the blue color and start to handle the brightness, it will only handle the brightness of the blue channel. But if we went to the green or red, it will be similar to the original and kept with the default values. You can decrease the contrast of the green, increase the contrast of the red, and by changing any of the three values here, it will reset other channels. So we here have increased the contrast, and if you went to the green channel and decrease the contrast of it and return it again to the red channel, you will find that it's returned to zeros. So you can manipulate any channel individually, and if you are working with a specific channel, it will reset all other channels. ImageScope provides also analysis tool from the view menu or pressing Ctrl+G. It provides three algorithms here. We are going to deal with the first one, positive pixel count. All of them are handling the positive pixel counts but with different versions and algorithms. The aim of the positive pixel count algorithm in the ImageScope is the ability to quantify the amount of a specific stain in the whole slide image, and you need to specify a color and three intensity ranges, weak, positive, and strong, and for each pixel that satisfy the color specification, the algorithm will count the number and intensity sum in each intensity range, and for each pixel that satisfies the color specification, it will give the pixel whether it's weak, positive, or strong. So as you see here, when we selected the positive pixel count 2004, you can define in the input options the width and the height. You can define the hue, value and width, and the saturation. You can also specify the different levels. W here means the upper limit of weak positive pixels, and S here means strong positive pixels. By playing and updating the values here, you can distinguish between different levels using the intensities based on the hue and saturation. For example, if we pressed on Analyze and then selected Analyze View, it will start based on the initial values to analyze the whole slide image or the whole view in front of us. It's processing, and after it completes, it starts to identify each of the region based on the hue and saturation to a specific class. If you press again, you can also apply real-time tuning of the settings you are getting by simply using this window and put it in a specific region. You can also enlarge that region and play with the different configurations, and based on these configurations, the region you are selecting or viewing currently will be updated. For example, if we have increased the saturation, you will see that most of the region converted to blue. Let's decrease it to, for example, that value. Let's update it. You can also change the hue width and value if you need. Let's increase it to 0.7. You can also handle the ranges of the weak, medium, and strong regions if you need. Let's stop tuning. You can also use that tool to analyze a specific region you have annotated. For example, let's draw a rectangle around this region, and then you press on Analyze to select an action, and then you press on Analyze Annotations. It will start to analyze the annotations in the current view, as you see here. And if you closed the Analyze option, the analysis of that annotation will be kept. You can also access it using the Annotations menu. As you see here, the first layer contains a single region, and the analysis of it will be described here, such as the algorithm version and name, different configurations, pixel area, hue value and width, and so on. You will find here also a set of values for the number of weak positive pixels, number of positives, number of strong positives, and so on. So you can use these values as biofeatures or biomarkers that can be also used in your classifier. You will have different annotations. Each of them is classified or analyzed using the positive pixel algorithm. Also, these features can be exported using this button to export a grid to Excel spreadsheet. If you press on it, you can simply export, for example, test. As you see here, it's exported to test.xls, which is an extension to Microsoft Excel, but an older version. Let's open it. It will present the different features for each of the regions. So if you have multiple regions here, you have annotated, for example, 25, you will have 25 records that can be used as features to your classifier or model based on numerical features instead of images. You can close all images or close a specific image if you don't need to deal with it currently. Let's close all images. As we have manipulated the image with the name 05, it will ask if you need to save what you have annotated and analyzed. If you need to save it, press on yes. If you don't, press on no. What about if you have saved a file and you need to open it again? You simply will open that image. For example, let's open A02, because A02, if you went to the description of the dataset, PACH dataset, you will find that all slide images that is prefixed with the letter A is annotated. So if you simply sorted them by name, you will find, for example, A02 with the annotation with the extension .xml, and also A07 with the extension XML, which is the annotation of the whole slide image with the same name. So simply, if you open the annotated file that you applied annotation on it, or you have downloaded a dataset with a specific annotations or predefined annotations, the annotation will be imported to the ImageScope. As you see here, it will be loaded with annotations made by clinicians and doctors, as described in the dataset description. As you see here, some regions are benign and some regions are invasive, and each of them differ on the severity of the cancer tissue. So in this lecture, we have dealt with ImageScope application, know how to download it, make different annotations, create different layers, and annotate different regions to a specific layers. And then we handled the annotations menu, how to add descriptions and text to it, and then how to analyze the different regions and manipulate the different options. And finally, we have learned how to open annotated whole slide images that we have previously annotated or predefined annotations by other people.